this is graphics programming, I guess. Okay, so this point I have highlighted in green. This has a coordinate, so let's just say it'll have like 0, 0. We also call just like any point like a vertex. So this will be called a vertex. Now, when you're drawing a shape, you'll want to have multiple vertices. So we can have 3 vertices to draw a triangle. And everything a computer draws is actually a triangle. For example, let's say we have a square. So I've outlined a square in red. And actually, when computers are drawing the square, they will split the square into 2 triangles because triangles are simply the easiest shape for computers to draw. So now that we have these 3 vertices, what we do is we can have them, like, for example, in blue, this is going to be 0, 0.1, 0.2. And then we tell the computer, not the CPU, but the GPU, that there is going to be a triangle that is connecting points 0, 1, and 2. And we send that to the GPU along with these vertices coordinates. Now let's talk about the shader. The shader sort of tells the GPU how to render this triangle that we just made. Now obviously we have one primitive, which is this triangle, and there's actually 2 types of shaders. There's a vertex shader and a fragment shader. Now this is sort of complicated because there's 2 types of shaders. Now, which do you use for which things? Well, the vertex shader is used for things that apply for these vertices. I mean, the name literally specifies it. It's pretty obvious. But basically, the vertex shader, it can be used for stuff like transformations. Like, for example, if we want to move this triangle from one side to the other, it's kind of bad color. I'll do it in another color. If we want to move this triangle from one side to the other, we would use the vertex shader because it allows us to do transformations. We can also use the vertex shader to scale the triangle up because scale is also another transformation. We can also use the vertex shader to rotate this triangle because rotation is another sort of transformation. Now, the fragment shader is used for actually, like, filling in the pixels of this triangle. So, for example, if we had this triangle like this, basically the vertex shader can make this triangle, like, yellow, or orange, or blue, or bright magenta. Any of these colors, it could work. And basically how it does this is for every single, like, the GPU actually uses a process called rasterization to draw these pixels. So if you think about your computer screen, it's a grid of pixels. Like, it just is a grid of pixels, and pixels are squares, obviously. So how do we render a nice triangle on there? So let's say we have this grid of pixels, right? And then I'll just draw the triangle using, like, a red overlaid over these pixels. Basically, it's also the GPU's job to sort of rasterize the triangles and figure out which pixels to fill in. So, for example, it might fill in this pixel and this pixel, this pixel, this pixel, this pixel, this pixel, this pixel to sort of rasterize the triangle. Now, obviously, your screen has way more pixels than 30 pixels. Oftentimes screens will have like millions of pixels, which means you'd obviously get a higher resolution triangle than this, but you get the point. The fragment shader, it's called on every one of these pixels. So the fragment shader decides the color for every single one of these pixels. And in case you're wondering, the word shader, if you think about like normal computer program, a shader is just a program that runs on the graphics card, the GPU. And this shader, it's actually called like simultaneously. It uses multiprocessing, not the multiprocessing like in CPUs, but actually graphics cards unlike CPUs, they're really good at doing one simple thing, but like doing it 1,000 times all at the same time, which makes it really good for doing this. Because oftentimes, how this fragment shader is run is it'll be run at the same time, sort of for all the pixels, and it'll just be multi-processed through. Now, a CPU couldn't do that because it doesn't have nearly enough threads, but since a graphics card is mostly like just purely focused on rendering graphics, it's often specifically made to run a ton of things at the same time, which is really cool. Now, another thing we can do is pass these things called uniforms into the shader. Now, basically what uniforms are they allow us to pass values from our code in the CPU, which I can like circle, over to our shaders. Like, for example, what we can actually do is this. Let's say we have, I don't know, let's say we have, actually I'm just gonna make a new one. So let's say what we have is we have like we have a variable we want to pass in. Like, for example, we have the color. So we can have like in, I'll actually just divide the screen up to make this more clear. On this side, it's the CPU code, and on this side, it's the GPU code. We'll just be focusing on the fragment shader for this example, but obviously, this also works for the vertex shader. But essentially, let's say we have a value on the CPU. It's a vector 3, and it represents the color we want in 0 to 1. So, for example, the color could be 1, 0, 0, and the first value represents the red channel, the second value represents the green channel, and the last value represents the blue channel. So this color would be like just pure red, pure bright red. Let's say we wanted that. So remember, this is just the vector 3. This isn't specifying color. This is just used to directly transfer the bytes of this vector 3 over to the GPU. So it'll take the binary, it'll first take this vector 3, convert it into binary, like, this is obviously not the actual binary, don't trust this, and then it'll just basically throw this value over to the GPU and be like, hey, here's the value we want you to use. And now the GPU, they can use this value in their code. So they can have like a uniform variable, like uniform vector 3, and they can call it like color or something. And now, basically what they can do is, using this color variable, which was passed in from the CPU, they can actually use it to do some cool stuff. Like, for example, they can use it to, like, set the fragment color. And the fragment color is basically the color the color the fragment shader wants the specific pixel to be rendered as. And they can just set the fragment color to that color variable. So this way you can pass in values from the CPU, which is actually really cool and really useful, especially when you think about the vertex shader. So for the vertex shader, how it works is you can use things called transformations. Transformations, essentially, they are just taking a matrix, like a 4x4 matrix, like, I don't know, like this. Like, they're just taking a 4x4 matrix of numbers and using this matrix. So let's just call this matrix, I don't know, M. And then just multiplying this matrix by this, the vector 4 position, which is given in the vertex shader. Like, a vector 4 position, which is given in the vertex shader. And they're just multiplying them together and setting the position to that. And I won't get into the matrix maths and the vector 4 math, because that's really, like, pretty complicated. But essentially what this allows you to do is it allows you to apply some weird transformations to to our triangle, or like primitive. It allows us to do stuff like this. make the color, obviously, and then we can also make, like, for example, after the transformation is applied, we can make the triangle bigger, which pretty useful. We can also make the triangle go to the side. Another thing we can make the triangle do is rotate. And also using transformations, one really cool thing you can do is to actually duplicate, like make copies of this triangle using transformations. It's really cool because you can form fractals like the Sierpinski triangle. And I'm not very good at drawing fractals because unlike a GPU, I can't do a ton of stuff in parallel. But you get the idea. You can do a ton of cool stuff with transformations, and transformations are and when you're using graphics programming for something like a game or a game engine, transformations are used a ton because of just how useful they are. So yeah, that's the basics of graphics programming. Hopefully you enjoyed.